Now that we are already syncing by pushing and pulling from a certain database that is in the cloud to a local database, a SQLite database that we already have defined, it's time for us to actually call the sync async method. And this will have to happen from the first page that we ever load. And in the case of our example, that will have to happen from the history page. Remember that in the history page, we're going to be listing those posts that are also available from the map page and from the profile page. But it becomes important that directly from the history page, we make that syncing. So once we pull the data from here or push any changes from here, of course, the data is still going to be in our local database. So the part where we can do that call is from the onAppearing. But if you remember, we are also implementing some functionality for pull to refresh in our list view. So it will be important that we do that syncing from here as well. Just try to identify in any application that you are building where it makes sense for you to start a syncing process. Either because you have just opened the application or certain changes have been made, or because the user is requesting that syncing. So let's do in the onAppearing the first call. Right after calling the update posts method, that by the way will have to suffer some changes in just a minute, we are going to be calling from the Azure App Service Helper, for which we of course need a using directive, the sync async method. And of course, we know that this is an async method, so we should await this call. If we want to await it, we will have to mark the onAppearing as async. And we are also going to have to do this same thing. In fact, let me just copy this one from the refreshing. Remember that this event handler is going to be called when the user pulls down the list view for it to refresh. So we're going to be calling this after the update posts method as well. And this is everything for us to call the method. And the method is already going to be pulling and pushing and handling any errors or any problems that may happen as the push is performed. But there is another very important change that we have to make. And that will have to be made directly from the post class. In the post class is where we are already inserting, deleting, and reading from the post table. But until now, we are still doing it through the mobile service and getting the table, and this is no longer the way in which we should do it, because if you remember, we have already gotten the table in a different format in the get sync table, but the table is already there. So there's no need for us to do this anymore. And in fact, because we have already implemented local syncing, this makes no sense because this will still be making all of the requests directly to the cloud database. The only change that we have to make is to call the appropriate table, which is still in the app, and it's simply called post table. This posts table also contains an insert async method, so we can insert in the same way that we had done before. But after inserting, we have to make sure that we push the changes to the cloud database. So in addition to inserting from the app and through the mobile service, we want the sync context to be updated. So we call push async again, just like we did in the other method. And this is an async method, so we will have to await it. And we will also need to add another using directive, which will be the Microsoft.Windows-Azure.mobile services. So once we have that directive, we are able to call the push async with no problems. Now this exact same change will have to happen in the delete method. Instead of calling from the mobile service the getTable method, we simply get the posts table. Delete async is still there, and we will also need to call the push async. we need to call the push async in both these scenarios because we need to both update the cloud database when we insert something new or when we delete something from it. And finally, when we read, we also can get the elements from the posts table. Remember that the first time from the Azure App Service that we pull from the post table to the posts table variable, we didn't make any filters. So the filter can be performed right here through the where clause, and we are still going to be needing to call the toList async, but now everything is happening from the posts table, which means that everything is going to be read from a table that is already available locally. So all these requests will happen almost instantaneously. Now let's go ahead and test our application. Currently, I am going to be able to read elements, but for the first time, it may take a while, not that long because it is a very small database, but the first time we will need to pull from the cloud database. So here's the application up and running, and of course the first thing that I have to do is to log in, and because I didn't implement any functionality for a local database for the users table, these will need to always make a request to the internet, which should probably be what you always do when logging your user in. But as soon as we enter the application here, the first thing that will happen is that everything is going to be pulled. Well, after pushing any changes, which currently there aren't any, the pull of the information is going to happen, and we are going to be receiving all of these elements to the local database. And of course, the application will work in the same way as before. The benefit being that now, every single time that you read from the table, it is first going to happen from the local database. And in the case of our application, we don't have it implemented, but if you were to save the user that logged in, if you run the application again, these will be read from the local database even when there is no internet. If you have another type of application and you want to test that this is actually happening, in the case of this application, we cannot precisely do it because we need internet connection to log in our user. But if you wanted to test it, you can always go to app.saml.cs and just, for example, change even just a tiny letter from the URL for your mobile service client, which will of course result on errors. You wouldn't be able to read from the cloud database, but you should still be able to see the elements that have already been synced to your local database. So there you have it. This is how you can implement offline synchronization between your cloud-hosted SQL database and the locally hosted SQLite database.